Hey there, folks. All right, really quickly, just want to talk to you about percent error. If you haven't done the lab yet, this is new. If you already did the lab, this is review. So anytime a measurement is made in science, in a laboratory, etc., there is going to be some error, depending on your measuring equipment, depending on the fact that you are human, etc. The formula for calculating this is found on the back page of your reference tables. Percent error is the measured value minus the accepted value divided by the accepted value times 100. What do those things mean? The measured value is what the student or the scientist measures that we know has some error in it. Okay, that's the measurement that has some error. The accepted value is kind of like the perfect value. The average of all the scientists in the world agree, okay, this is what the perfect value should be, or this is the value that we're going to put in the reference tables. This is accepted by all scientists as the best value. So in the formula, you're taking the difference between your measurement and the accepted perfect value. Then you're dividing it by the accepted value. So you're comparing it to the accepted value. Then you're multiplying by 100 to turn it into a percent. Let's look at a couple examples. All right, in this problem, what's the measured value? What is the accepted value? A student determines the density of zinc to be 7.56 grams per milliliter. If the accepted density is 7.14 grams per milliliter, what is the student's percent error? I'm not going to have you calculate it, but just look at the problem again, try and figure out what's the measured value, what's the accepted value. Okay, the student determines. That means that's the measured value for the density of zinc. There's some error in that. The accepted value, the perfect value that comes from the reference tables is 7.14. It's in this problem, they call it the accepted value. That makes it easy. Okay, here's another one. Ooh, this one's a little harder. Okay, what's the measured value? What's the accepted value in this problem? We've got a data chart with density information about graphite, okay, and about diamond, both forms of carbon. Let's focus on number 55. A student calculated the density of a sample of graphite to be 2.3 grams per centimeter cubed. Show a numerical setup for calculating the student's percent error for the density of graphite. Again, I'm not going to make you calculate it. Let's just figure out what is the measured value, what is the accepted value, so you could plug them into the formula. Take a moment, hit pause. All right, there's the measured value. The student calculated this. So the student did some measurements and they calculated their own density for graphite. The accepted value is what's given to you in the chart, okay? This might sometimes be in your reference tables, or it will be given to you as the perfect value, okay? It says the density for two forms of carbon are listed below, all right? So that's gotta be what is the accepted value. It's the only other thing in the problem. All right, in this problem, what's the measured value? What's the accepted value? We don't have to solve this one this time. A student intended to make a salt solution with a concentration of 10.0 grams of solute per liter of solution. When the student's solution was analyzed, it was found to contain 8.90 grams of solute per liter of solution. What is the percent error in the concentration of the solution? I know there are some words here you don't know. Solute just means the stuff that you dissolve, okay? We'll learn about that later. But let's figure out what's the measured value, what's the accepted value. Hit pause, try it. Okay, the student made some mistakes. And later it was measured that, okay, their experimental solution contained 8.90 grams of solute. They were supposed to make it 10.0 grams of solute. So the perfect solution would have been 10 grams per liter. But the student made it and came up with 8.9 grams per liter. So now we can use those to calculate the percent error. Okay, and thanks for watching. Make sure you watch the other video from today too.